So before I talk about the actual properties of logs, this is actually kind of a derivative of one of the properties, I guess you can say. What? We haven't talked about E properties yet. These properties are based on exponent properties. Since logs are exponents, it makes sense that the properties of exponents would be somehow tied into the properties of logs. Okay, so before I show you this, I promised you something. I promised you that I'd show you how to use your calculator to evaluate logs. And I haven't shown you yet because I wanted to quiz you first to make sure that you understood before.
Do they do it on the side?
So, yes. So, let's just take the one off of your, yes. Alright, log. Let's do the base 1/2 of 8 because this was on your quiz. And in glancing through, most of you got this one.
3.
1/2 to the what power gives you 8? -3. Alright. One cool thing about logs is that we can take any log that needs evaluating. These are easy because they come out to nice whole numbers, right? But everything doesn't. Anything, if I have log base b of a, I can change this to log of a divided by log of b, and something's missing here. What's missing on my logs now? Your base, right? You can put anything for the base as long as it's the same thing here, and this formula works. So the nice thing is your calculator only does one base. It does a base of what? 10. Okay, so if you take out your calculator, what I'm getting at is here, I could do log 8 divided by log of, and I'll need to put parentheses since that's a fraction, 1/2, and see if you get -3. It's magic. I know, but I wanted to make sure, I wanted to concrete your understanding of logs before I showed you just how to go to the calculator and do it. Will says he's good. Let's see. Log base 3 of 8. Now this one, if you think it through, there's nothing you can raise 3 to get 8, right? So I know it's going to be somewhere between 2 and 3, closer to 2, right? Because 3 squared, actually between 1 and 2, closer to 2, I'm sorry. Because 3 to the second power is 9, right? And that's a little too big. Huh? The lesson? 4.5.
1.89?
I don't know. I haven't done. Log 8 divided by log 3. So what you got? You do have it, Wills. Good job. 1.89, right. So we've done a lot. No, we've done a lot of evaluating, and you've used your little half sheets because they're exact whole numbers, but we'll get into some that are not, so you'll need to know how to do this. Remember, there's another log function on your calculator that you could use just the same. What is it? Because that's log base E, right? Same thing if I did natural log of 8 divided by natural log of 3, I get the same thing. The point I'm getting at is the base doesn't matter as long as it's the same when you're dividing, okay? That's actually called change of base formula, but makes sense, right? Let's do some logs. There are 3 properties of logs. Now, if you think back, how many properties of exponents did we have? 7. We're condensing that down to 3. All right, the first one we're going to talk about. I think I'll give them to you, and then we'll work some examples of expanding and condensing. I think that'll be the easiest way. Keep your big boy and girl panties on because we're not solving until tomorrow. But the expanding and the condensing is where students get really bogged down for some reason. All right, so pay special attention as we go. Let's say I have log base b of x times y. Okay. Now, the base is the same, right? X times y. This x and y go together here with this log. So think about properties of exponents. If I'm multiplying with the same base, what do you do with the exponents? You add them, right? Well, because b is only written one time, that's the base. Okay. So I know that I can change this. This is just a little trick to help you remember why it works. Is because if you're multiplying with exponents, then you add. Then I can split this up as log base b of x plus log base b of y. If I go from left to right, that is called expanding the expression. Do you see why it might be called expanding? It's getting bigger. I'm making it longer. But if I start with the expression on the right and I make it look like the left, that is called condensing because it condenses it and makes it smaller. Does that make sense why we'd say expand and condense? Okay. Again, I think the easiest thing to do is to give you the three properties and then we'll put them all together. All right, property number dos. Spanglish. It never does. Remember when I gave you the properties of exponents and y'all were like, those are easy, those are easy, those are easy, those are easy, and then we put them all together and you went,
I have a question about that. So since the base is usually the same like log e, you just add the x, y,
Well, you have to split it up, each one of them having a log. So it'd be log base b of x plus log base b of y. You have to include, you can't just do log base b of x plus y. You actually have to write the log twice.
Solve the log bx and then add one.
Right.
Do you have to have this?
Shh, guys, I feel like I'm fighting for your attention again. Huh? No, you don't have to have the parentheses. Because this is multiplication here, it's included with it. All right, the next one. These have names too. That was the product property. This is the quotient property. You don't have to know the names of them. Let's say instead of multiplying, let's say I was dividing. And no, you don't have to have the parentheses. I'm just putting them there to let you know that they both go with it. You subtract. You're absolutely right. Yeah, you're absolutely right. We subtract. We split it up. Log base b of x minus log base b of y. Somebody said you subtract and they knew you subtract because when you're dividing and you're talking about exponents, then we subtract when we divide. So same thing with the logs. Again, from left to right is expand. And from right to left is condense. Let me spell it right. The third one is the last one, and it's the one everybody finds the easiest. Yay! Y'all are so cute. That is an x raised to a y. When you take an exponent and you raise it to another exponent, what do? You multiply. So what happens here is the y comes around front and multiplies to the log base b of x. Yes, yeah. No. You would do the log and then multiply it by what's in front. Expand, condense. Sandwiches just give me some problems.
Wait, what's the point of putting expand and condense? Every single one of them is
You could start, if you start here and I say condense this expression, then you'd write it like it's written to the left. And if I start with the left and I say expand it, you'll see when we do several examples. Not on this. All right, let's do some examples. Because I'm hearing I don't understand and it looks easy. Some people are saying it looks really easy. Some people are saying they don't understand. Let's do some examples. I'm sorry. I think it's easy. But, all right, the key to these is same base, just like it was with exponents as we go through. You think hard first before?
No. You look at, yeah, we need to look back into them. What was the first problem?
expand, condense.
Power property. All right, I want to expand this. It is completely condensed. Do you see why it's condensed? There's just, it's logs written one time, so it's completely condensed. Okay? So as I expand, what property, this has got more than one property in it. This has actually got two properties.
It's the product and the
It is. So the question is, which do I need to do first? Well, the product. And here's why. If I brought this 2 around front now, and listen because this will get you every time, I need y'all to pay attention. If you bring this around now, if you were to write this as 2 times log base 7 of 5x, that would say that the exponent went to both the 5 and the x. When in fact it doesn't, it's only hooked to the what? To the x. So I need to make sure when I split it up, it's only going to go to the x piece and not the 5 piece as well. Then you would do that one first. Yes. All right. So this I don't want to do, and that's why. So I'm glad y'all said that because that's someplace everybody gets stuck. All right. So if I do the product property first, what do I do? How do I expand that? Log base 7 of 5 plus. Does that confuse anybody? Multiplying means to add. Where are you confused? Yes. Unless you see parentheses there, it's only hooked to the one it's closest to. Yes, we will. Yeah. So you want to split up multiplication and division first unless the exponent applies to everything. Alexis, do you see how we split it up? Because this is being multiplied, and multiply means add.
Oh, okay, I see.
unless the exponent is to everything.
Yep, unless you see the exponent to everything. What now? Move the 2. So I have log base 7 of 5 plus 2 log base 7 of x. Now it's right. See, the way this was, it was going to both of them, but now it's only going to the x. Yeah. Yes or no? That's your answer. That's expanded. No, we're not solving today. We're solving tomorrow.
No, it's all right.
Just stop.
Well, we're gonna learn about it, it's just gonna be
That's just tomorrow.
That
No,
also
no, I'm talking about.
Oh. My bad.
Wait, if there's a 2 in front of the log,
Yeah.
why does it apply to X?
Because the X had.
Because there was no parenthesis here. A parenthesis would indicate that it went to the whole piece. It went to the 5 and the x. But because there was no parenthesis there, only the x is squared, not the 5. All right, so take a look at this one. Let's do log base 6 of 5x cubed over y. We do have all three here, okay? Take note on what is grouped together if it helps you to do parentheses. In other words, I could put a parentheses around this top this way to know that all that stays in the numerator, because if I have multiple pieces in the denominator, that would impact my signs, because remember, division means to do what? Subtract, okay? So we're going to do one that's flipped in just a minute like this. Do what? No, this is a harder one. Split up your fraction. Always split up. If you're multiplying or dividing, always split that up first. All right, so I want to do log base 6 of 5x cubed minus. Then it would be applied to both of them. Well, you'd still need to split this up first.
So the one on the top has to go into this.
Yes. Now that first piece, I can leave that last piece alone for right now, right? And what I was telling you about these parentheses is if it helps you, see if these were flip-flopped, when I went to split this up, I might have a sign issue because everything after the subtraction sign has to be subtracted. So you might want to do that. You don't have to. In this case, it's not going to impact the answer, but yeah, not on this one, but the next one we do, you'll see why it's helpful. So now the question is, do I bring the 3 around front first, or do I split the 5 and x cubed up? Split the 5 and x cubed up, because there's no parentheses around the 5 and the x, right? The cubed is only going to the x. So now I have log base 6 of 5 plus log base 6 of x cubed. All that was the numerator, right? Minus log base 6. Bless you. Isn't this fun?
Yes.
Thank you, Wills. You get bonus points today.
So much fun.
Thank you. You too, Chandler. Thank you. I appreciate the confidence. Me too. 3 goes around front. So now I have log base 6 of 5 plus, and again, the parentheses are not really necessary here. A lot of this is just continuing to write what you wrote before with one extra little step in it. What do you think so far? You guys take your time. Oh, we're going to do lots of condensing. Condensing is usually easier, I think. Let me do one more expanding where I've got multiple pieces in the denominator rather than the numerator so you can see what happens, because there is one like that on your test, so I want to make sure I show you that. All right, let's say one more expanding, and if you got it after this, we'll move on to condensing. And then there's specific values I need to cover. Oh. Y'all, contain your excitement, please. My goodness. All right, expand. Ooh, What do you do first? So, yeah, subtract. Always split that fraction up first. Let that always be your first step when you have a fraction, to split it up.
Is that a 2?
Oh, good job, Wills. It's a little different. It does. It does. All right, so I'm going to split it up. As Wills already found, the 3 applies to both this time. A little bit different than what we had before. Okay? Now, I'm going to do this because I want to make sure everything that was in the denominator stays being subtracted. Yeah, you can, as long as it's not everything at one time. Like I would probably, yeah, that's fine. Like I would probably come here and do this and this at the same time.
Wait, right now?
Mm-hmm. Now notice I'm bringing the 3 around first, and that's because as Will's told us, sorry. It's hooked to both, right? Now we add on, yep. Some of you are ahead. Okay. I'm fixing to split these up with addition. Yes, so this 3 is going to go, in fact, what I do is I do parentheses. Yeah. You could write, so there are multiple ways and there's not one that's right or wrong. You could do 3 log 5/8 plus 3 log 5y. Okay? Like it could distribute to both of those pieces. If you didn't, now you're good stopping here, okay? If you didn't though, you could also write it as 2 log base 5 of x minus 3 log base 5 of 8 minus 3 log base 5 of y. See this negative in front? That's why we have the parentheses. Take special note of what that looks like in the expanded form versus up in the condensed form, okay? Because if I give you one that's double subtraction, both of those pieces at the bottom, both of those pieces to the right are in the denominator. Do you see that?
Wait, so anytime there's coefficient,
I have a question.
Go. Yes.
I have a question.
Okay. Yeah.
How will we understand outside algebra
Pre-cal.
with logs like this? Like
Pre-cal.
specifically? Like, is there any profession like specific?
Sure.
Because
Lots of professions.
we do.
There's one on page 261. Sound intensity sound waves are logarithms. We talked about Richter scale as logarithms. There's lots of things that are logarithms. Sing. All right, condensing. Condensing's a little bit easier, I think, because there's it's easier to recognize the order in which to do things, I think. I would do exponents and then left to right as you move through it. And that's going to help you condense correctly. So, for example, let's say I have, let's do a hard one. Log base 7 of 3 plus 2 log base 7 of x minus log base 7 of 5 minus 3 log base 7 of y.
So,
This is going to condense to look almost like what we just did. Y'all are whining about it, but it's very
The
close.
addition is your numerator and the 2 negatives are your denominator.
That is correct. That
And
is
then you just gotta
correct.
combine.
So let's do, guys, if y'all spend as much time concentrating as you do whining, you would be in much better shape. All right, let's start with all the power products that we see. Okay, in other words, numbers in front being multiplied. Okay, and let's just rewrite just with that power property. So log base 7 of 3 plus log base 7 of x squared. Does that confuse anyone? Okay. All I did was bring the exponents around. That's it. Now let's move left to right and let's just do 2 at a time. Let's don't take it any more than that. Okay? In other words, let's look at the first 2. How do those combine? 3, you're going to multiply. That's exactly right. These 2 become log base 7, 3x squared. And then I'm just writing the rest. It looks bad, but it's really not. I keep copying from the line above. 2 at a time, 2 at a time, 2 at a time. Don't try to do more than 2 at a time. That's when you're going to mess up. All right, next 2. You're going to divide, right? It hasn't gotten hard yet. These are all the basic properties. Do we all agree? Nothing been too hard yet? Is anybody confused?
Nope.
Okay. Log base 7, I'm dividing, minus log base 7 of y cubed. Now I'm down to just 2. Subtraction means to do what? Divide. So here's the question. When you have a fraction and you're dividing something by it, in other words, let's say I have let's say I wanted to do 2/3. What is it? 2/3 divided by 5. What would you do?
Multiply by the reciprocal.
Multiply by the reciprocal, right? I do 2/3 times 1/5 and multiply here in the bottom. Right? I'm going to apply that same property here. If I do 3x squared over 5 divided by y cubed, what I'm really doing is multiplying by 1 over y cubed. Do we agree with that? So this becomes log base 7 of 3x squared over 5y cubed. You can if you can see it.
Wait 1 second, please.
Yes. Does that make sense? When I wrote it, y'all went, oh my gosh, stop. But to me, that's easier than expanding.
Yeah.
Usually students do better with the condensing than the expanding. Y'all got it? Una mas, where we do this, I'm going to put some exact numbers and then I've got to show you one more thing. I'll be done. Let's say I have log of 9 plus 3 log of 2. I don't know why that 3 looks like that. Minus log 3. Exactly. The base is 10. Good job. So I want to condense it and simplify it. What should you do first? The powers. This one's a little bit different because there's not variables in this, and that's okay. So I have log of 9 plus log of what? 8. Good job. Since these are exact numbers, I'm going to go ahead and write them. What now? First 2 pieces. Multiply. Somebody said add means multiply. That's right. This becomes log of what? What's 72 divided by 3? See how nicely that condensed down?
See, but once you got log of 24, how would you?
Well, if it asked you what's the log of 24,
Yeah, but when you condense it?
that is condensed.
No, I mean expand it. I'm sorry.
You want to expand from a number like that, and except what I'm fixing to show you.
Okay. There's always one more thing.
Let's say, this is to me the easiest, and I do not understand, but students struggle with it. There are 2 like this on your test. It's on your homework. It's not a really hard concept, but I'm not sure why. It's just more practice with expanding and condensing, really, is what it is. Let's say I tell you that the log base 6 of 5 is approximately 0.898. And I know that you can use your calculator to do these, but that's not the point. The point is that we can do them by hand this way. The log base 6 of 8 is approximately 1.161. That's it. I'll stop there. What if I asked you to use these two values? Yeah. Use these two values to tell me what is the log base 6 of 40.
5 times 8 is 40.
5 times 8 is 40. That's exactly right. So what I'm trying to do is I'm trying to rewrite this using multiplication, division, or exponents, because that's how I know I can expand with the numbers that are given, 8 and 5. Okay? So, you're right. This would be log base 6 of 8 times 5. The reason I do this is because then I can expand that to be what?
Log base 6 is 8 plus log base 6.
Now I just sub in the information that was given. What is log base 6 of 8? What is log base 6 of 5? What do you get when you add those two things together? I'm fixing to see how smart you really are. Zero.
Oh,
Wait, we have to.
she just robbed it. She just robbed it. You just turned that smile. Log base 6 of that number.
Let me move it to the other side.
Wait, hold on.
Oh.
Oh my God. You're putting.
That's all you can use. So you got to find some way to use 5 and 8, multiplication, division, exponents to come up with the number
wait,
320.
this is a totally different problem.
Yes, that's why it's in a different color.
All right.
And why I'm sorry.
No, lost.
Alright.
I wish I could do my maniacal laugh. No. So the exponent can be any number, but what you're multiplying and dividing has to be a 5 or 8. But you can raise it to any power you want. What'd you say? That's correct. Say it another way. Use an exponent. Yes. That was what I wanted you to see.
You wanted to use the 8 squared.
8 squared times 5. No. So if I expanded this, I'd have log base 6 of 8 squared. Now, it's not wrong if you did 8 times 5 times 8. Because this is going to come around and say 2 times log base 6 of 8, which is the same thing as saying log base 6 of 8 plus log base 6 of 8. So you could do it either way. It doesn't really matter. This is usually where everybody struggles. Are y'all sure this is easy?
You need to stop and you can mix the
Yes, yes. So log base 6 of 8 is 1.161, and log base 6 of 5 is 0.898, and then you would get what?
So that's 2.322.
Plus 0.898 is what?
3.3.
Yeah.